University of Utah called Click and Clone. So what we're going to do is we're going to clone Mimi, this brown female mouse. So we're going to use Mimi that we will be cloning. We are going to use Megdo. Megdo is going to donate the gamete. She's going to donate the egg cell, and then Mommy is going to be the surrogate mother. So she's going to provide the womb. And then materials we're going to need a microscope, some Petri dishes, a sharp pipette, a blunt pipette, and a chemical called Stimulate a lot. So we're going to isolate the somatic cells from Mimi and the gametes from Megdo. We're going to remove the nucleus from the egg. We're going to transfer the somatic cell's nucleus into the blank egg cell. We're going to cause it to go through cell division, and then we're going to implant the embryo into Mommy the surrogate, and then we're going to see what we get. All right, so here we're going to take a somatic cell from Mimi, and we're going to take an egg cell, a gamete, from Megdo. Now, we want Mimi's DNA, so we're going to get her DNA and put it into the egg cell, but we don't want Megdo's DNA, so we're going to get the DNA out and, I don't know, put it down the drain. I don't know where it's going to go. All right, so we're going to move the Petri dish with the egg under the microscope. We're going to connect this blunt pipette to hold it in place and go in there and get Megdo's DNA. So suck it out there and toss it down the drain. Now this egg, it does no longer has the genetic material from Megdo, but we're going to put Mimi's skin cell or hair cell in there, and we're going to transfer it directly into the egg. So we're going to hold on to it, this blunt pipette, take the sharp pipette, and suck out Mimi's DNA and then stick it into the egg. So no fertilization here. We take the DNA and put it straight into the egg. And then this takes a little time for the DNA and the egg to kind of get accustomed to each other. Hence the egg timer. Well, now we need this egg to be a certain size before we can implant it into the womb of Mommy. So we're going to add some Divide-A-Lot. Now this can also be done with electricity. The other video you watched on cloning talked about using electricity, but this is using chemicals. And what we're looking for is a ball of cells called a morula that is 16 cells. And now we're ready to implant into Mommy, our surrogate. There it goes. So it's 19 days of gestation for mice, so 19 days to carry the mice. So if you have a mouse problem in 19 days, you could have a bigger mice problem. So we're going to click on the mouse and see what we get. So is this going to be brown like Mimi, who donated DNA from her hair, from her skin? Is it going to be black like Megdo that donated the egg? Or is it going to be white like Mommy that donated the womb? It's going to be brown like Mimi, because Mimi gave the genetic material that was put directly into the egg cell, and then that egg cell without fertilization already has DNA in it, already has 46 chromosomes in it. They put in the chemicals, they zap it with electricity, and it starts going through rapid mitosis. So did this really happen? Yes, this did happen at the University of Hawaii in 1998. So here is Megdo, our egg donor. Here's Mimi, our somatic cell donor, donated her skin or hair. Here's Mommy, our surrogate mother, and then here are the little mini Mimis.